Hello everyone, welcome to IIT and GATE classes. This will be our lecture 3 on TOC. Okay, so in the previous lecture, we have started construction of FA. That was the second topic according to the syllabus of your second chapter. For the first topic was introduction to FA, which I have already completed in the second lecture itself. Okay, so now in the second lecture also, I have completed this first category of questions on construction of FA, that is ending with something. Okay, so in this lecture, that is the lecture 3, we are going to start the second category of questions, that is starting with something. Okay, and I hope I will be able to complete all these 7 categories in this lecture itself. Okay, so in this lecture we are going to complete the construction of FA topic. Okay, so let's start with your second category, that is starting with something. Okay, so the first question is starting with A. Okay, this is very basic question and very simple. You will be easily able to design FA for it. Okay, so let's start. So let me this is your initial state, say Q naught. Okay, this is your initial state Q naught. Okay, now when A is applied, we will move to state, say Q1. Okay, and since we are saying that starting with A, so Q1 must be final state. Okay, why? Because we have to accept single A also. Okay, so let me give you idea about the language itself. Okay, first let's see the language. Language will be what? Starting with A, na? So smallest string will be A itself. Null won't be accepted because null is not starting with A. So null string must be rejected from this FA. Hence we have not made, see, we have not made initial is final, because when we say initial is final, that means null string is accepted, and null here is rejected because null is not starting with A. Okay, so smallest possible string will be A. Next will be double A. Next will be AB, then ABA, then ABB dot 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 dot. Okay, so A, after A we can have anything. Okay, so since this is your final state Q1 is your final state, then at Q1, okay, either A can come or B can come, we will remain in this final state only. So this is your FA. Okay, now tell me one thing, whether this is NFA or DFA. Okay, tell me this thing, this is NFA or DFA. I hope you have got your answer. Actually this is NFA. Okay, why this is NFA? Why this is NFA? Or first try to answer this question, that is this NFA correct or not? See, this NFA is correct. Why? Because starting with A, na? So A is accepted, then double A is also accepted. See, after reading 1A, we will move to Q1, and on Q1 we will read A, then we will remain on Q1 itself. So double A is accepted, AB is accepted, and so on, everything is accepted. This NFA is correct. Now tell me this thing, that why this is NFA, why it is not DFA? Because on Q1 we have read A and B, it's okay, and on Q0 we have read A. Okay, on Q0 we have read A, but where is B? So hence this FA has a dead configuration, that is on Q0 we are not allowed to read B. That is a dead configuration, and that configuration is allowed only in NFA. It is not allowed in DFA. Okay, so no doubt we do not have any choice here. There is no choice. Okay, but still that configuration is present, hence it's not DFA, it's NFA. Okay, so tell me, when we want to convert it into DFA, then where B will go? Okay, on Q0, whenever B is read, we cannot move to Q1. Obviously we cannot move to Q1, because if we, after reading B, we are at Q1, then Q1 is your final state. Then starting with B, all strings which starts with B, that will also be get accepted, but we do not want to be we do not want them to be accepted. Okay, so B, after reading B from Q0, we should not jump to Q1, we should move to a separate state. Okay, let's take this state as Q2. Now see this thing, very simple. On Q0, as soon as you read a B, that means what? String has started with B. Now if string has started with B, then it will never be accepted. Since it will never be accepted, so we will have a loop of A and B on this Q0 itself, and we call this state as a trap state. Okay, we call this state as a trap state. So trap state may be needed in DFA, but in NFA, we do not need a trap state. Rather, the work of trap state is done by that configuration itself. Okay, so if question came in exam starting with a minimum number of states in NFA, minimum number of states in NFA will be 2 here. Okay, now, minimum number of states in NFA will be 2 here. What about DFA? For DFA, we need 3 states. Okay, why? Because we need one extra trap state in DFA. Okay, because that configuration is not allowed, so we need a separate trap state. And whenever at q naught b is read, that means what? String is starting with b, and all those strings which starts with b must be rejected. So we come to a trap state. Why we are calling it as trap state? Because whenever a DFA come to this state, then it cannot move out of this state. It will be trapped in this state. Okay, that's why we call it as trap state, or some authors say them as dead state, trap or dead state. Okay, trap or dead state. Okay, I hope I have made the point clear to all of you. So this is starting with A. Next is starting with double A. Again, very simple. Okay, a similar idea we will use here also. So let's build it. Initial state will be our q naught. Q naught will be our initial state. Okay, whenever A is read, we will move to Q1. Okay, so I hope you are getting an intuition about how we are designing all these NFAs and DFAs. Starting with double A means what? The smallest possible string. Let me say you something about language. The smallest possible string will be double A. Double A must be accepted. Then obviously triple A must be accepted. Then double A B must be accepted. Then B must be accepted, A must be accepted, and so on. All these things must be accepted. So after reading double A, anything can come. Okay, so similar idea only. So after reading A, we move to Q1. Then again after reading A, we will move to Q2 state, and Q2 state will be our final state. Because we have read double A, Q2 will be our final. And after reading double A, we do not need anything. Now, each and every string will be accepted after reading double A. So on Q2 itself, we have made a self loop of A comma B. Okay. Now, tell me something about this. Is this NFA or DFA? This is obviously NFA. You know? This is NFA. Why NFA? Because here also we have that configuration. That is what on Q naught. Okay, on Q naught, where is B? On Q1, where is B? So we have to give move for B also. So similar idea, we will make a trap state here also. Okay, so we will try to make trap state here also. Okay, so on B, we will move to state Q3, which will be our trap state. Okay, and on Q1 also, after reading B, we will move to Q3 itself. Okay, so your DFA is completed now. So NFA, we need how many states? For NFA, we need only 3 states, and for DFA, we need 4 states. Okay, so please do not get confused. Presently, this entire thing is your DFA. Okay, but if we remove this dead state, then this is nothing but your NFA. Okay, I hope I have made the point clear to all of you. Okay, let's move to next question. Okay, so let's move to next question. Next is starting with AB. Okay, let me tell you one thing more. Starting with A, I have completed. For your homework, okay, for your homework, you will make starting with B. Okay, you will make NFA and DFA for starting with B. Very similar case. You can easily design it. And in the next slide, I have made starting with double A. So in the homework, you will make NFA as well as DFA for starting with double B. Starting with double B. Okay, let's move to next slide. Starting with AB. Starting with AB is very simple. Similar idea. So you just have to focus on the smallest string first. Okay, so this will be your initial state Q naught. Okay, and on Q naught, okay, this is your initial state Q naught. Now on Q naught, whenever A is read, we will move to state Q1, and whenever a B is read, we will move to state Q2. Okay, Q2 will be our final state, and on this state, since string has already started with AB, see, since a string has already started with AB, so anything can come after it, it will be accepted. Okay, so so starting with AB is completed. Okay, now tell me something. Whenever say A is this NFA or DFA? This is your NFA. Okay, so NFA need 3 states. NFA need 3 states. Okay, now I want to convert it into DFA. For DFA, what we have to do is on Q naught, if B came, then we obviously know we will move to a dead state. Okay, and we will have a self loop of A comma B. On Q1, whenever A came, then obviously we will move to dead state itself. Okay, so I hope I have made the point clear to all of you. So this will become your DFA. So DFA will have 4 states. Okay, please remember all these things. Rather, no need to remember all these things in exam. If the question came, then you can easily design it. You can easily design it and count the states. Okay, so in the homework, I hope you have got it now. In homework, you will design starting with BA. Okay, you will design NFA and DFA for starting with BA. Very similar. I think you can easily design. Okay, next category. Now second category is over. Next category is starting and ending with something. See, first category was ending with something. Second category was starting with something. Now is starting as well as ending with something. Starting and ending with something. So the first question is starting with A and ends with B. Okay, start with A and end with B. Okay, so let me make the English clear to all of you. It must be start with A and end with B. Okay, so let's start it. So smallest string which will be accepted will be what? So tell me something about the language first. Okay, so smallest string start with A and end with B. Obviously start with A, end with B, that is AB. Next possible string will be A B. Next will be A B B dot 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 dot, all these strings. So start with A, end with B, in the middle we can have anything. Okay, so very simple. So on the Q naught state itself, okay, so in the Q naught state itself, so in the Q naught state itself, we will read A and move to next state. Okay, move to next state, say Q1. Okay, in the Q1 itself, see, we can read anything now. So we can have a self loop of AB, and after reading B, we will move to state Q2, which will be our final state. So tell me something about this. Is this NFA or DFA? You can easily tell that this is NFA. Okay, why this is NFA? Because we have a choice here. Now we have a choice of B here. So on Q1, after reading B, we can move to Q1 also, and we can move to Q2 also. Okay, and there is that configuration also. On Q2, we have not given the moves for A and B and so on. So this is NFA. And tell me something, that is it correct or not? Intuitively, you can check this is correct. Why? Because see, I have already told A, B, and in the middle we can have anything. So this is nothing but what? A, and this is B, and in the middle we can have anything. Okay, in the middle we can have anything. So this is correct NFA, and you can check it out also. See, smallest possible string accepted will be AB, and like this. On reading A, we move to Q1. On reading B, we move to Q2. AB is accepted. Double AB. On reading A, we move to Q1. Then A on Q1 itself. Then after reading B, we move to Q2, and so on. You can check it out. NFA is perfect. Now tell me something. How will we will convert it into DFA? So DFA conversion is very simple. Okay, so let me tell you. Okay, so let's make it this way. Okay, let's make it this way. So on Q naught, okay, whenever A is read, we will move to Q1, and on Q1, whenever B is read, we move to Q2, which will be our final state. Okay, so smallest possible string AB is accepted. Now what about A's? So on Q1, if A came, then obviously we will have a self loop. Why? Because after reading A, any number of A's can come, and then whenever B will come, we have to accept the string. Why? Because it is nothing but starting with A and ending with B. Okay, that's why A will have self loop. Okay, so on Q1, we have already completed, say Q1 we have already completed A and B. On Q0 we have completed B. What about my A? Obviously you have already guessed right, that on Q1 whenever B will came, we will move to a dead state. Okay, that is, and on dead state we will have move A comma B. Okay, so now A and B of Q0 is completed, A and B of Q1 is completed, A and B of dead state is completed. On Q2, what about A and B of Q2? Q2A. On Q2, whenever A will came, then tell me something where where we should move. Okay, so when we will reach Q2? After smallest string is AB. After reading AB, we are at Q2 state. Okay, see this thing. After reading AB, we are at Q2. Now, whenever A will came, we are in search of only B. As soon as B came, then we will say that string is ending with B, and hence it must be accepted. So after AB, whenever A came, then we should not remain at Q2. That is, we should not remain at final state, because it is not starting with A and ending with B. Rather, it is ending with A only. Okay, so as soon as A came, we should move to a state which after reading B will take us to again a final state. So that state is Q1. Okay, so on Q2, whenever A is read, we should move to a state on which as soon as we read B, we should move again to final state. Okay, so that state is Q1. Okay, so after reading A, we will move to Q1. Okay, what about my B? Obviously Q2 will have self loop of B. Okay, why? Because after reading AB, we are at Q2, and on Q2 we can read any number of B's and still string is ending with B, starting with A and ending with B. So hence B will have self loop on Q2, self loop of B, and on Q2 A will take us to Q1. Okay, and I want to give you one kind suggestion, that on Q2 never think of taking A to Q0. If you take on Q2, whenever A is read, if you take to Q0, then on Q0 after reading B, we will move to a dead state. Okay, so please draw an imaginary line whenever we have a dead state type of thing. Draw imaginary line like this. Okay, and never come back from these states. Okay, never come back from these states to this state. Why? Because if we come back from this state to this state, then we can have possibility of going to dead state, and which will, you can say, reject most of the strings. Okay, I hope I have made the point clear to all of you. Let us take a small string, then you will get more clarity about this concept. See, after reading AB, we are at Q2, and after reading A, if we move to state Q0, then after reading B, we will go to dead state like this. You can imagine all these things. Okay, so AB string will be rejected, and after B, we can have anything like A, B, A, B. Each and every type of string will be rejected because we will be at the dead state itself. Okay, so this is my kind suggestion to all of you. Rather, this is a rule that whenever we have a dead state on the initial state, then from other states never jump to initial state, because that may lead us to a dead state, and most of the string will be rejected in that case. Okay, I hope I have made the point clear to all of you. Okay, so start with A and end with B. This is your final DFA, and it is taking 4 states. Okay, let's move to next slide. Next is start and end with different letters. This is again very simple case. Start and end with different letter means what? Language accepted will be what? Smallest possible string will be AB, because it is starting with A and ending with B. Next string will be BA, because starting with B and ending with A. Okay, start and end with different letter. Now, to start and end with different letter means what? Start with A and with B, or start with B and with A. Okay, we can have any possible thing. Okay, so next type of string will be A, B, or B, A, dot, 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 dot. So we have two formats: A, then anything can come, then B, or B, anything can come, A. Okay, so very simple. We can construct DFA or NFA very simply. So at Q0, okay, we will initially we will be at initial state Q0. Then after reading A, we will move to state Q1. On Q1, we can have self loop of A comma B, because that means what? Anything can come. After reading B, we will move to state, say Q2, which will be our final state. Okay, so this is starting with A, ending with B. Now starting with B, ending with A will be again similar to this thing only. After reading B, we will move to state say Q3, and we will have a self loop of A comma B, and after reading A, we will move to Q2. Okay, now please do not think like this, that sir, you can have a doubt. Okay sir, why not you are taking B here itself? Okay, why you are making a separate state? Please pause the video and try to answer this question, that on Q naught after reading B, why we are going to Q3, why we are not going to Q1 itself? See, if you go to Q1 na, after reading B you go to Q1, and here also after reading A you move to Q2, then string accepted can be A, only double A will be accepted, double B will be accepted, and double A is not starting with starting and ending with different letter. So that will create hell lot of problem. Hence we have made a separate state, that is Q3. Okay, so on Q naught after reading B, we will move to Q3, and on Q3, we will have a self loop of AB, and then after reading A, we will move to Q2. Okay, so tell me something, that this is NFA or DFA, and is it correct or not? See, obviously you can guess that this is NFA because we have a dead configuration here, and here we have a choice. On Q1 after reading B, we can move to Q1 also, and we can move to Q2 also. So we have choice as well as dead configuration. Hence, this is NFA, not DFA. Now, if you want to convert it into DFA, what you have to do? Okay, see, very simple. This is very simple scenario. Or let me tell you something. See, please note it down. So for NFA we need 4 states. Okay, please pause the video and note it down. And now I am going to change something here. Okay, so first and the very basic thing which will come to our mind is remove this B, okay, because this will create obviously this is creating choice, and after reading B we should move to Q2, so remove this B from here, that is A and B. Okay, this you all can easily remember. Okay, next is on Q3 after reading A we can move to Q2 na, so why we are having self loop here? Because smallest string BA should be accepted. So if you have self loop of A here, then obviously BA will be rejected na. Okay, so we have two choices na. Either you keep this self loop, okay, either you keep the self loop of A, or you move from A to Q2. On Q3, either you can remain on Q3 and you can move, or you can move to Q2. So which is the better choice? Obviously on moving Q2 is the better choice, because smallest string BA should be accepted, it should not be rejected by DFA na? Okay, so we will remove this A from here. Okay, now see, AB of Q1 is completed, AB of Q3 is completed. See properly. AB of Q3 is completed. AB of Q2 is completed. Okay, and AB of Q0 is also completed. Okay, so now what we are left is, we are left with Q2, A and B of Q2. Where A and B of Q2 will go? Now we have to check this thing. See, this is very simple. Just try to visualize one thing. Just try to visualize one thing, that is, after reading starting with A and ending with B na, after reading AB you are at Q2. Since you are at Q2, so after AB any number of B's can come and still string will be accepted. Why? Because it is starting with A and ending with B. So you may think that we should have a self loop of B here. Okay, but if you have a self loop of B here, then what about this case? If you came to Q2 from this path, then after reading BA you are at Q2. Okay, after reading BA you are at Q2. So after reading BA you are at Q2, and since we have a self loop of B on Q2, so BAB will be accepted. This will create a lot of problem for us. So B should not have self loop. But if you are following this path, then B should have a self loop. If you are following this path, then B should not have a self loop. Okay, so what should be done? So the main problem here is, please listen carefully. The main problem here is on Q2, whenever DFA is at state Q2, then it is not able to remember the path, from which path it has came, from either from this path or this path. It does not know these things. Okay, hence If you want to make df in such a way that it should remember the path, then we have to bifurcate, or you can say we have to make two final states. Okay, then it can remember. So let me make this point much clear to all of you. Okay, so let me design here itself. Okay, so q naught. Okay, on q naught, whenever a is read, we will move to state q1. On q1 we will have self loop of a. After reading b, we will move to state q2, which will be our final state. So this will be starting with a and ending with b, and comfortably we can have self loop of b here. Okay, now next thing is, if we read b on q naught, if we read b, then we will move to state q3, and on q3 we will have self loop of b. Okay, and as soon as a came, we will move to state, sorry for that, we will move to a new state. After reading a, we will move to a new state, that will be q4. Okay, and q4 will be obviously again a final state. Okay, and on this final state, obviously we will have self loop of a. Why we will have self loop of a? Because after reading ba, we are at q4, and then we can read any number of a's. Okay, and still we will remain at q4 only. Okay, so this will be so on q4 we will have self loop of a. Now next thing will be what? On q4, see, till now most of the things are already completed. Of q0, a and b moves are completed. Q1, a and b moves are completed. Q3, a and b moves are completed. Q4, b is completed. What about my a? What about my a on q2? If a came on q2, then tell me something. Smallest string is ab. After reading ab, we are at q2. On q2, if a came, then we are in the need of just one b, and then we will move to final state. And whenever we have a need of only one b, okay, so the state must be q1. On q1, after reading b, we are moving to final state itself. Okay, so hence its a will came here only. Similarly, its b will came here only. You can check it out. Okay, so this will be my final nfa. So this will be my final dfa. Okay, and every dfa is nfa also, so do not get confused about all these terms. Okay, so for nfa we need minimum 4 states. For nfa we need 4 states, and for dfa we need 5 states. dfa need 5 states. Okay, this is very good question, and I hope all the concepts related to this these are clear to all of you. Okay, now let's move to next question. Next is start and end with same letter. Next question is start and end with same letter. So first of all, try to identify the language. Language will be what? The smallest possible string will be null. Null is what? Start and end with same letter only. That is, nothing is present, so you can imagine it is starting and ending with same. Okay, next string will be a. Next string will be b. Why a? Because it is starting and ending with same letter only. B starting and ending with same letter only. Okay, then double a, then double b, then a, b, b, a, dot, all these strings. Okay, now see carefully. We have already constructed language dfa for a language start and end with different letter. Okay, and start and end with same letter is nothing but the complement of the previous language. Okay, so in case of complement, please remember this fact. This is very important fact, and I am writing it carefully. So please write this thing, that to a complementary machine. Okay, complementary machine except complementary language. Same question came in GATE exam itself. A complementary machine except complementary language. complementary language. This is true for DFA only. This is true for DFA only. Complementary machine means what? Complementary language you already know, है ना? Complementary language is this only, ना? We have already studied this. Complementary language means what? See, the previous language was started with different letter, and then this is started with same letter. So these are complement of each other. So complementary language. Okay, what is complementary machine? Complementary machine means make non-final as final, non-final as final, and final as non-final. Final as non-final. Okay, final as non-final. If you do these things, then we get a complementary machine. Okay, for example, in the previous slide you have already studied this, na? This is your DFA, na? This is DFA for what? Start and end with different letter. Now if you want to construct DFA for start and end with same letter, that means what? Complementary machine, sorry, complementary language. So complementary language will be accepted by what? Complementary machine. And this is true only in case of DFA. This is not true in case of NFA. Please remember this thing. Okay, so complementary machine means what? Non-final to final and final to non-final. Okay, so if you want that I should write mathematically, then I can say like this. See, L of M, okay, M is a machine. So L of M bar, that will be equal to L of complementary language. Na, complementary language is accepted by complementary machine. Na, so you will apply bar here. This is the mathematical way of writing. Okay, this is what M bar means. What? Complementary machine. M bar means what? Complementary machine. Complementary machine. And this whole LM bar means what? LM bar means what? Complementary language. Okay, complementary language. I hope I have made the point clear. So LM means what? LM means language accepted by machine M. LM means language accepted by machine M. Language accepted by machine M. LM is language accepted by machine M. So LM bar will be what? Complementary language. So LM bar, okay, here bar. So this is nothing but complementary machine. So this is true in case of DFA. It is not true in case of NFA. Please remember this fact. I have said this thing many times now. Okay, so I have repeated many times. Please remember this fact. So now what you have to do is just copy paste this DFA and make final as non-final, non-final as final. You will get the DFA for this machine, for this language. Okay, for same letter. Okay, so let me do it. Let me do it. Okay, so Q naught. Okay, so after reading A, we will move to Q1. After reading B, we are moving to Q2. Q2 was our final, na? So please do not make it final. Reading B, we are moving to say Q3. On reading A, we are moving safe at Q4. Q4 was final, na? Please do not make it as final. Now here we have self loop of A, we have self loop of B, we have self loop of B here, self loop of A here. After reading A, we move here, and after reading B. Okay, after reading B, we are here. So now these two were final, na? In the previous slide, see, these two were final. Okay, so in the previous slide, these two were final, na? Q2, Q4. Now in place of these two, we will make all these three as final. This will be final. Since initial is final, so null will be accepted, and we already know that this language contains null. Okay, null is present. Okay, so null is accepted. Then single A must be accepted. Okay, so this is final. Single B is accepted, so this is also final. Okay, I hope I have made the point crystal clear to all of you. Okay, so see, no need to explain all these things again and again. I have already made this point clear. Now this is your homework that you will check it out, that why this is correct. Okay, take some strings and try to answer this question, that why this DFA is correct. This is homework for you. Why DFA is correct. Why DFA is correct. Try to take smallest string and try to accept them. Null is accepted, single A accepted, single B accepted, double A accepted, double B accepted, and so on. AB rejected, BA rejected, and so on. You can check it out. Okay. Okay. So now let's move to the next slide. So this is starting and ending with same letter. Okay, next category is substring. Substring is very simple. Double A substring, very simple. See, language will be what? Smallest string will be double A, then B double A, then double AB, then BAAB, then AAA, then AAB, A dot. So in the string you should have double A. Somewhere you should have double A in the string. Say here double A is present, 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 and so on. Okay, so we can visualize it like this: double A, and starting we can have anything, and in ending we can have anything. So just map these things. This is very simple. On Q0 you can have anything, na, A, B. On reading A we will move to Q1. On reading another A we will move to Q2. Q2 will be our final state, and on this we will have self loop of AB. I hope I have made the point clear. This is very intuitive and very simple also. Okay, so is this NFA or DFA? You can easily guess this is your NFA. Why this is NFA? Because we have dead configuration as well as choice. Where is the B of Q1? Similarly, on Q0 we have A and B. So on Q0, after reading A, we can move to Q0 and we can move to Q1 also. We have a choice here now. So this is NFA. Choice and dead configuration both are present. Hence, this is NFA. So now try to convert it into DFA. This is very simple task. Okay, so please pause the video and note it down, and I will do it here itself. Okay, see, A na, since double A must be accepted, smallest string is double A, na, double A must be accepted. So on Q0, A should not be here. A should take us to the next state. Okay, now what about A? What about sorry, on Q0 A and B is already completed. Okay, so no need to worry about it. So let me write B here itself. Okay, see, on Q0, okay, so on Q0 B and A is already completed. Q1 A is completed. What about my B? On Q1, as soon as B came, okay, see, take the example. Smallest string is A, which will take us to Q1. Or we can have B also. Na? Any number of B's than A, we are at Q1. At Q1, as soon as B came, then again we are in the need of double A itself. Okay, and again we are needing double of A. Again we are in need of double A. That means what? We should move to Q0. Because on Q0, after reading double A, we can move to final state. So its B will go to Q0. Okay, I hope I have made the point clear. Now see carefully. This is perfect DFA itself. Okay, see carefully. This is perfect DFA. On Q0, A and B are completed. Q1, A and B are completed. Q2, A and B are already completed. So now we got DFA itself. Okay, so I hope you have already paused the video and note down the NFA. Now I have converted it into DFA. Okay, okay, so double A substring I have completed. Now in the homework you will design for what? Double B as substring. Double B as substring you will design yourself. Next is AB as substring. Again, very simple. I should not waste the time. I will make it very fast. Okay, A comma B, anything can come on Q0. Then after reading A, we will move to Q1. After reading B, we will move to Q2. Q2 will be our final state, and we will have self loop of A comma B. Now this is perfect NFA. We will convert it into DFA. How? Okay, and this is your homework. You have to prove that why this is correct and so on. Try to take some strings and try to guess yourself. Okay, this is very simple case. Okay, so now A will be deleted from here. Okay, so we will have B here. Okay, now A and B are completed. On Q1, whenever B will came, then we will move to Q2. And what about my A? See, this is very simple. After reading A, you are at Q1. Now you can read any number of A's, and even then B came, then we should move to Q2 because AB will be substring. So on Q1, we will have self loop of A. Okay, now see, this is a perfect DFA to complete it. Okay, so I have made it very fast. Please try to follow all these things. If you are not able to follow, then please rewind the video and watch it again. Okay, so this is your ABI substring. Now in your homework, you will construct BA as substring. Okay, I have made it fast because I hope you already have guessed the DFA, and the best way is whenever I am showing you the question, then please pause the video and try to make DFA and NFA yourself. This is the best way. Okay, so in homework you will complete BA as substring. Okay, so substring category is over. Now we are jumping to divisibility category. Okay, divisibility category, that is number of A's are divisible by 3. Okay, so this is your fifth category. Number of A's are divisible by 3. This is very simple. See how we will design number of A's are divisible by 3. First of all, we are not talking about B here. Okay, and actually this is not you can say complete portion. I am writing in the shortcut way to save the time. I have already told you that we are taking sigma as A comma B. Okay, or sigma is 0 1 and so on. Binary alphabet we are taking. Okay, so two symbols we have. So we are not concerned with B now. We are only concerned with A's, that is number of A's should be divisible by 3. Okay, so number of A's divisible by 3. We are not concerned with B. So number of A's divisible by 3 means what? After reading A, we will move to state Q1. After reading another A, we will move to state Q2. And whenever a next A came, we will move to Q0. And Q0 will be our final state itself. Why? Just because number of A's are divisible by 3. First, try to give me an idea about the language. Language will be what? Smallest possible string in which number of A's are divisible by 3 is null only. I am repeating again and again, we are not concerned with B's. We are not concerned with B's. We are concerned with A's only. So smallest possible string will be null. Null should be accepted. Since null should be accepted, so initial must be final. Okay. Next string must be, say, forget about B's for now. Triple A must be accepted. See, triple A is accepted. Now A power 6 must be accepted, and 6 A's must be accepted, and so on. You can check it out yourself. This is very simple case. Now tell me something about B's. Where we will take the B's? Okay, so next single B must be accepted, double B must be accepted, and so on. The main concern is if you have triple A's, then here we can have any number of B's, 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 and so on. So B can be anywhere and any number of times. So what? We will have self loop of B. We will have self loop of B on each and every state. I hope I have made the point clear to all of you. So the number of A is divisible by 3. This is the perfect DFA. This is perfect DFA. Okay, when I was teaching in offline classes, now some student came to me and they said, sir, if you want to construct NFA for it, then we should remove all these things now, and we will say that this is NFA. Please pause the video and try to answer this question. Is this the NFA? No, this is not NFA. Why? Just because, see, obviously this is one of the NFA, but this NFA is not accepting this language in which number of A's are divisible by 3. This NFA is not accepting that language. Why? Just because single B. Just leave everything, talk about single B. Single B is accepted or rejected. This will be rejected by this NFA. Single B will be rejected. Why? Because this is dead configuration. On initial state, we are not allowed to read B's. So single B will be rejected, but single B must be accepted now. So this NFA is not accepting the language of number of A's are divisible by 3. So please remember this fact. Okay. So we have to have self loop of B's here. We have to have self loop of B's here. Okay, please remember all these things. Okay, so single B accepted. Then see, now I hope I have made the point clear to all of you. No need to repeat again and again. If you have any doubt, then please rewind the video and watch it again. Okay, so this is perfect DFA, and since every DFA is NFA, so this is NFA also. No need to worry about all these things. So how to construct NFA and so on. This is NFA already, and this is DFA also. Since this is DFA, so hence it is NFA also. Okay, number of A's are divisible by 3. and we are not concerned with B's. So on B, on seeing B's, we are not shifting any state. On B, we are at Q0 only. On B, we are at Q1 only, because we are not why we are not shifting state? Because we are not concerned with B's, and so on. Okay, I hope I have made the point clear to all of you. Okay, so number of A's are divisible by 3. This is over, and we need 3 states. Similarly, you can design number of A's are divisible by 4, number of A's are divisible by 5, and so on. You can design yourself. These are very simple cases. So divisibility by 4 means what? You should have another state Q3. After reading A, you will move to Q3, and from that A, if on Q3 we read A, then we will move to Q0 itself. Okay, I hope you have got this point. Divisible by 5, number of A's are divisible by 5, number of A's are divisible by 6, and so on. So number of A's divisible by n, that will have n states. This is a shortcut. Number of A's divisible by 3 means what? We have 3 states. Number of A's divisible by 4 means what? We should have 4 states, and so on. Okay, so this is a number of A's are divisible by 3. Now let's take an example. See, here we are not concerned with B's. Na? In the next case, we are concerned with B also. That is number of A's. Okay, number of A's are divisible by 3, and number of B's are divisible by 4. Just pause the video and try to answer this question. Sorry. Yes, so I hope you have tried. Now let me answer this question. This is a standard question actually. Number of A's are divisible by 3, number of A's are divisible, number of B's are divisible by 4. So now we are concerned with A's as well as B's. So try this. So try to remember this shortcut. Number of states will be what? Number of states will be 3 into 4, that is 12. Okay, so shortcut is number of A's divisible by m, number of B's are divisible by n, so number of states will be m multiplied by n. Okay, you should remember this shortcut. Number of states are 12. So let's arrange these 12 states like this. Okay, so or let me make some bigger circles so that we can make it properly. Okay, 4 we are taking horizontally. Okay, so we will make 3. Okay, 3 stages like this. So now we have got the 12 states. Now try number of A's are divisible by 3, number of B's are divisible by 4. Number of B's are divisible by 4 na. So arrange B's here. This will be just like a grid. This is known as grid automata, and this is a standard way of making a grid. Number of B's are divisible by 4. So try to construct it like this. B, 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 and B. Here also B's, 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 and B. Now this will be your initial state, and for A's we will do like this: A, and A. Again here also A. Okay, let me take different color, that will give you a much better idea. For A's we are having this line. Okay, A's A, 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 A's A, and A. Okay, so this is your you can say. Okay, so this also I should make with the red color, so that symmetry will come and it will look more beautiful to all of you. Okay, so let's do it now. A, and A. Okay, so I hope I have made the point clear. This is just like a grid. Okay, this is known as grid automata. So whenever condition on both divisible on number of A's are divisible by m, number of B's are divisible by n, so total number of states in grid automata, grid FA will be m multiplied by n, and we have directly constructed DFA. You can check it out. Each and every state A and B's are completed. Okay, So now what will be our final state? Initial state is okay. I think you have already guessed. This will be our final state itself. Why? Number of a's are divisible by 3, number of a's are divisible by 4. So smallest possible string in the language will be null. Why? Because null means nothing. Nothing is present. So number of a's are divisible by 3 because 0 is divisible by 3, and number of b's are divisible by 4 because 0 is divisible by 4 also. Okay, so number of a's in null string, number of a's are 0 and number of b's are also 0. Okay, I hope I have made the point clear to all of you. So null string must be accepted, hence initial must be final. That's it. Okay, now let me tell you one few more things. Okay, so let me label this way with sorry, with blue color I will be labeling horizontal states. Okay, so 0, 1, 2, 3. Okay, and with red I will be labeling vertical states. 0, 1, 2. Okay, now we have a very beautiful shortcut. Listen it carefully. If I make this state as final, this means what? Forget about this state. Okay, forget about this state. Forget about your initial as final. If I make this state as final, this means what? See, here we have 1 and here we have 0. So I will say number of b's when divided by 4 gives remainder 1, and number of a's are divisible by 3 because remainder is 0 for a's. Okay, so this state final means what? Number of b's when divided by 4 gives remainder 1. Number of b's mod 4, we should say like this, number of b's mod 4. Okay, mod 4, that must be equal to 1, and number of a's mod 3, that must be equal to 0, and apply and here. Okay, number of b's in what? Number of b's in w na. So let me take it properly. Number of b in w. Okay, I should say properly, number of b's in w mod 4 is equal to 1, number of a's in w mod 3 is equal to 0. Okay, similarly if I make this state as final, see this state as final, please tell me something about it. This state final means what? Number of b's in w mod 4 will be, see, remainder 2, and number of a's in w mod 3, that will give us remainder 1. Okay, so this state final means what? Number of b's, please pause the video, note it down, then I am changing these things. Okay, so number of b's in w mod 4, that will be 2, and number of a's, so that will be 1. Okay, why we are doing mod 4 with b's? Because we have already told na, number of b's are divisible by 4, and we have 4 state here na. See, we have 4 state here and 3 states here. Okay, I hope I have made the point clear. This is very basic things. But one last question. When we make this as final, then this means what? Okay, you can easily answer that number of b's in w mod 4, that will be 3, that will be equal to 3. Okay, and number of a's in w mod 3, that will be equal to 2. Okay, this is the shortcut, and if you want to prove all these things, then you can easily check it out from initial state. Now we are starting from initial state. Whenever we are reaching this final state, this means what? See, triple b double a. So number of b's mod 4 is remainder 3, and double a means what? Number of a's mod 3 remainder will be 2. Okay, so triple b double a, and if you came from here, then double a triple b, again same thing. If you come from here, b a b b a, so again 2 a's and 3 b's. If you came from here, a b b b a. Okay, you can check it out. Okay, now I have told you many things. This should be just like a toy for you. Try to play with it. Okay, the more you dig deeper in this topic, you will get more and more idea about all these things. Okay, I have just given you hint, you can check it out yourself now. Okay, now let's move to the next question. Number of A's and number of B's are even. This is a very beautiful question, and this question came in GATE many times. I don't know why the professors have a very deep friendship with this question, but this question has came many times in GATE. Number of A's and number of B's are even. Even means what? Divisible by 2. So what can I say? That number of A's are divisible by 2, number of B's are also divisible by 2. Okay, so let me take it this way. Number of A's divisible by 2, number of B's divisible by 2. So number of states will be how many? 2 multiplied by 2, that is nothing but 4. So 4 states now. So let us build 4 states. Q0, Q1, Q2, Q3. Okay, and even number of A's and number of B's should be even. Even means what? Null should be accepted or not? Yes, obviously null should be accepted. So initial will be final. Why? Because 0 is divisible by 2, and so on. So initial will be final. Okay, so just try to make the grids in the similar way. On reading A, we will go to here, and after reading A, we will come back here. A here and A here. You can reverse also. Okay, no problem. B here, B here, B here, and B here. That's it. So this is your perfect DFA, directly DFA. This is again a grid automata, and 2 multiplied by 2, that is 4. Okay, so let me label these things. Okay, so A and B. So number of A's are even here. Okay, or let me do it this way. Let me do it this way. Again, try to label all these things. So for A's, okay, so remainder 0, remainder 1. Okay, for B's, I am writing here. For B, remainder 0, remainder 1. Okay, B's are moving like this now. Yes, see, B's are moving like this. So vertically B's are moving. So remainder 0 for B, remainder 1 for B. A's are moving horizontally. So as a remainder 0 for A, remainder 1 for A. Okay. Now try to answer the very basic question. If this is final, okay, we will now study many questions. If this is final, this means what? Number of A's are even and number of B's are also even. You can check it out. Null is accepted, then A, B, B. A, B, B. Okay, number of A's and number of B's both are even. Okay, so let me label this state as even. So A's are also even, B's are also even. This state will be what? Number of A's are odd, but number of B's are even. Why number of B's are even? Why number of B's are even? Because remainder 0 state. Okay. Okay. So odd even. So number of A's are odd, number of B's are even. This state will be what? Obviously, you have guessed this right. Odd. Number of A's are odd, number of B's are also odd. This state will be what? This state will be even odd. Number of A's are even, number of B's are odd. Okay, I hope I have made the point clear. Please try to play with all these things. This should be just like a toy for you. Okay, so okay, one more question is coming in my mind. If in place of and, if I have or, then what will be your answer? That means number of A's are even or number of B's are even. Number of A's are even or number of B's are even. That means what? Since we have or, that means if number of A's are even, then forget about B's. Number of A's are even, that means we should accept all these things. Okay, so number of A's even, as soon as we get number of A's even, forget about B's. Similarly, as soon as we get number of B's even, forget about A's. Okay, so now I think you have already guessed. Number of final states will be what? Q0 will be final, Q1 will be final, and Q2 will be final. Only Q3 will not be final, because Q3 says both are on. We cannot take both as on. We can take either, see, at least one is even, that means that string must be accepted. So here both are even, here B's are even, here A's are even. So all these three states will be final. Okay, all these three states will be final. This won't be final. Okay, so I hope I have made the point clear to all of you. Let's move to next slide. Next category is at least, at most, and exactly. Okay, at least 2A's. This is again very simple. Okay, at least 2A's. That means what? Language will be, we are not talking about B's, we are talking about only A's. So please remember this fact, only A's. So at least 2A's means what? Double A is the smallest thing which should be accepted. Double A B must be accepted. Triple A must be accepted. B double A must be accepted. Dot 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 dot. At least 2A's. Now we should have at least 2A's. And similarly, A B, this must also be accepted because it has at least 2A's. Okay, and A must be accepted, and so on. Okay, so how will you construct DFA or NFA for this? This is again very simple. Start from initial state Q0. After reading A, we will move to Q1. Smallest possible string is double A, na? Try to accept it first. Then talk about other things. Q2. Q2 will be our final. Double A is accepted. Now what about my B? At Q0, if B came, that means what? Any number of B's can came. Since we are not concerned with B's, so we will not change the state. We will remain here also. Similarly, here any number of B's can came because we are not concerned with these. Now we have 2A's. Then anything can come. Everything will be accepted. Now we have 2A's. So that's it. I think I have made the point clear. Directly, I have made the DFA. Okay. Now I think I do not need to waste any time on this. If you have any doubt, please rewind the video and watch it again. Okay, next is at least 1A and at least 1B. Okay, let me do it this way. I think time has already over. Okay, so I think I should not make lecture for more than 1 hour. So let me leave it here only. In the next lecture, we will study at least 1A, at least 1B, then at most 2A's, at most 1A, at most 1B, exactly 2A, exactly 1A, and exactly 1B. Then we will have finite languages 0 1 0 1 1 and A power n B power n is less than equal to 2. Okay, and then we will start NFA to DFA conversion. That will be our third topic according to syllabus of your chapter 1, that is finite automata and regular languages. Okay, so this will be your third topic. Okay, so we will study all these things in the next lecture itself. Okay, so in the so please try to pause the video and at least try yourself all these questions. So at least 1A, at least 1B, you will try. This is homework for you, and of course in the next lecture itself I will start all these things. Okay, at least 1A, at least 1B, then at most 2A's, then at most 1A, at most 1B, exactly 2A, exactly 1A, exactly 1B. You will do all these things. Then finite language 0 1 0 1 1, then A power and B power n is less than equal to 2. Then NFA DFA conversion will start from the next class. Okay, so till now, till this thing, okay, till this slide, try to make NFA DFA and so on. Okay, thank you so much. So we will talk all about all these things in the next class. Okay, bye bye.